Without limits, the future would be wholly unknown. From natural limits, we learn something about the problems and opportunities we face. Limits define the boundaries of the possible. And so we're talking about, in this presentation, the limits to growth of nanotechnology. And this is from chapter 10 of Drexler's book. And one thing he covers and asks is, if we are going to approach these limits, we need to know at least an idea of where those are. Because if it's anywhere between here and the horizon, there's really no progress that can be made if we don't have a way of sensing where those boundaries are. And so some of the limits that come are from the hardware itself. As we get smaller and smaller down to the molecular level of nanotechnology, there's good things and bad things that occur. And the molecular forces begin to kind of work against this idea of creating nanomachines specifically. As we desire to put nanomachines together and put nucleus closer and closer together, the positive and negative forces actually work against that. And so though we're wanting to bring nucleus together, the forces work against it, and you're not able to bring them into close proximity to create the machines. And then if you were to isolate the nucleus, you can't create the machines in the first place. Other limits occur from the energy use and the entropy that comes from that. The more energy we use, the greater entropy continues to grow, and the waste, heat, and disorder continue to grow steadily. And Drexler actually presents this example in order to kind of possibly negate entropy itself, and he uses the example of having salt and water in one container. And if you mix it together, you have salt and water, but then if you go through the process of evaporation, you get the salt again. And if we could do something similar with entropy itself, where we use all the energy, is there a way we can convert the entropy back into energy? And he says that one uncompromising exception is enough to invalidate an entire law. And so that could itself invalidate entropy itself. And another thing is that within our Earth, there may be certain things related to entropy and the laws that take place, but if we go out beyond our Earth, is there a possibility that those laws could change? If we go out into the solar system, out into the universe itself, do those laws remain the same, or would they change the farther we go? Another limit comes from resources, and is there a limit to our resources on this Earth? Because the more we continue to explore this field, our resources do begin to become less and less, but that's just on Earth, and the Earth is hardly anything compared to the sun, and then we have the solar system, and then the galaxy, and the universe, and it goes on, and there really is not a limit to our resources, so there doesn't seem to be as much of an issue there. Another limit comes from the possibility of outsiders, and are we really alone in this universe, or are there extraterrestrial beings that can hinder our ability to explore nanotechnology? And he basically says that it really doesn't matter whether or not there are extraterrestrial beings, because if there are, they may be so superior to us that they're going to override our plans no matter what. And so we can continue exploring that field without fear, because they would completely destroy it either way. And then if they don't exist, then we really don't have to worry about it anyways. And so he proposes this idea of growth within limits, of both the limits and the change, because expansion will continue to proceed as long as life spreads. The reality of those limits is independent of our wishes. Whether or not we like the idea of limits, they are there. We can't just kind of conjure up an idea that they don't exist. But at the same time, while there are limits that are accurate and that are firm, they do simplify things. Change is continuing to happen. And as those standards continue to change, those limits tend to become kind of gray, and they go into a sense of gray area. And as new technologies come, new art, then new standards begin to form. And so as we have this kind of strange balance of limits and change, it's hard to know where exactly we stand within nanotechnology. But Drexler encourages us at the end of this chapter to have genuine courage. And genuine courage requires facing reality, the reality of the limits, and facing the accelerating change in a world that has no automatic brakes. Okay, have any questions?
Could you expound on the entropy thing a little bit? That was kind of, I found that interesting.
Sure. Yeah, it's hard because he starts to begin to say that there's a lot, like the entropy continues to build and can hinder our ability to explore nanotechnology. But then he comes back around. It's hard to know where exactly he stands because he kind of presents it two-sided equation. But the one example he uses, and I'm not great at these sort of things, but he takes this container and he has salt on one side and water on the other, and then he combines the two, and they puts it in a certain part of the room where the sun is shining on part of it, and so it's able to evaporate, and then it goes back to the salt and the water, and they're separated again. And so is there a possibility where we could take entropy in this huge mass of waste and heat that we've made and convert it back into the original energy, which seems to go against everything that we've ever understood that entropy is continuing to build. But he poses the question of whether that would be a possibility. How does that make sense?
Yeah, I don't know if you got that quite right. I think Drexler got better on thermodynamics than that.
Yeah.
Entropy is never reversed.
Right, yeah, and that's why it was
Time
really
is
confusing.
that entropy is always increasing.
Because that's like a huge
And
law
when the
of
water
science.
evaporates, it's because more entropy is happening.
Right.
Any spontaneous change is going to increase
Yeah.
entropy. I think his argument's different than that. I forget exactly how it works, but not that you can reverse entropy, but he's hoping that there can be less heat loss using nano than the current methods, which are highly inefficient. So, yeah. But there's, you know, if you talk about cosmology, whether the universe is open or closed, those sorts of questions have to do with whether you can keep increasing entropy infinitely or not, right? So, but those are larger cosmological questions. All right, other questions for Ms. Perry? Okay, well, thank you. Give her a big round of applause here.